Hey guys, Meglinman here. Small video for you, the power supply diagram for the Smiljan Tesla Coil project. Just wanted to familiarize you with the schematic behind this. This has been posted as a JPEG in places, but I haven't really talked way through it yet. There will be a video coming up soon of all this mounted in a box, at least in CAD, and so that you can see, you know, what we're going for with this at that point. It'll take regular wall power in, just like any 110 outlet will work. They have to be at least 15 amps, and this is fused for 10. So the first thing we see coming off the wall is the fault lights for the AC power, and these will be on the front of the box so that when you plug in the box with the mains turned off, you're going to get lights on. Okay, so if it's plugged in and the mains are off, you're still going to see an indicator that there's power available to it. So if you hit the switch, something's going to happen probably. The AC power on light just says, you know, there's power between line and neutral. If there's power on the neutral line as opposed to the line, i.e. it's wired wrong, we put a light between neutral and ground. And if that light turns on, that means there's power on the neutral leg, and that's an issue. And then of course we want to make sure there's a ground available, so we put a light between the line and the ground, so that we should get the power on light and the AC ground light. If we get the AC fault light, we'll probably make it glow red or something, so hey, don't turn things on, things are a little weird. And that's a huge problem actually. It'll make sense here in a second, because if that's wired backwards, and somebody will probably yell at me, but if that's wired backwards, that means the variac is wired backwards. And so 0 is not 0. 0 is full on. And needless to say, that does bad things. So we need to make sure that there's no AC fault. It's got to be wired correctly. A main switch and a fuse on the back of the box in order to protect, you know, everything inside this thing and give you a way to shut it off. That'll just be a little rocker switch or something, 30 amp rocker switch. The variac itself will be mounted on the front of the box, and probably have the dial read 0 to 10, something like that. And if it's turned all the way counterclockwise, it's got 0 output. If it's turned all the other way, it's got 140% of the wall output. Okay. We get to that via a terminal block that's named 1, terminal block 1. Peg 1 is the neutral, peg 2 is the load, the line. Off of that, we're going to have a main power on light. So when you turn the mains on, you're going to get yet another light on the front of the box to let you know, hey, the mains are on. The other thing that's going to happen when that happens is the 2 meters will light up. Okay. There's a conversation about getting some antique meters together, at which point obviously it won't light up, but they'll light up because right now they're digital. If we do go with antique meters, actually, you know, it's not a bad idea, because usually you run coils in the dark, and putting some sort of lights in the meters might not actually be a bad idea. So there might be a version 1.2 if we get antique meters. So the voltage tripler is what it is. There's going to be a whole video on that alone, just so that it can make sense to all of us, because frankly, it's like black magic as far as I'm concerned. I'm a budding electrical engineer, I don't understand that yet. There's a shunt on the power output, the positive side of the variac, or I'm sorry, of the tripler, and the voltage drop across the resistor, which is very, you know, fine, exact resistor, goes into our amp meter, and it's like 0 to 10 millivolts or something like that DC. It's a very small amount of power, and that will tell us how much current is passing into our load, our bridge, whatever is out there on the other end of this thing. And then we have another meter, a volts meter, that is across the 2 legs, across the positive and minus legs, so that we can see how many volts are coming out, because obviously we have a variac, we're going to have 0 to 600-ish volts coming out of this thing, and it's important not to go too high. Turning it to 11, for instance, will cause it to have issues, because the meters themselves are only good up to 600 volts DC, but in the actual coil, the MOSFETs, the IGBTs, whatever, they're usually only good up to 600 volts. So if we cross a 600 volt line, we're officially into who knows what territory. And there's a couple of thoughts on that. I was thinking about, instead of having the load come down here to the opposite end of the variac coil, coming off this tap point here, so that it's impossible to turn it up past a certain point, or put a mechanical stop or something along those lines, just to prevent blowing up the meters and the coil and God knows what else, because the caps are rated for 600 volts in this layout. So there's a lot of things that can go wrong there. We're also going to toss a 12 volt transformer in the box, just so that the circuitry at the coil has the power it needs to run, because the primary runs on high voltage, and the circuits that run the FETs and everything along those lines runs on this 12 volts and 5 volts. There's power regulation out at the coil to handle that, so that's not an issue. The only thing I might have to do is add a bridge rectifier here in order to serve up DC instead of AC. So, alright, so that's a quick look at the Smiljan power supply schematic. If you guys see anything that I did wrong, or something that you think I should add, or anything along those lines, feel free to comment. This project's still, I mean, there's a lot of parts bought for it and a lot of parts secured for it, but they're not assembled yet. And so if anybody has any insights or suggestions on how to make things a little bit different or a little better, please comment, and go ahead and like the video while you're at it, and make a point of swinging over to the Geek Group here on YouTube and at their website at thegeekgroup.org, because this project is for the Geek Group. It's by the Geek Group. I'm spearheading it. It's my thing, but the end product will be there at the lab. So and there's this is kind of neat to me, but there are things there that are just superb, and a lot of stuff to learn and a lot of things to see, not just here on this channel. So we'll catch you next time.